We're going to be recording as per our usual system. And Bob, please begin your second presentation, which we noticed doesn't have a tilde over the N.
I couldn't find a tilde. I'm kind of computer challenged. The reason I'm doing this is because we are in a La Nina. You probably heard about that already. And it's been affecting us because typically the summer in La Nina will be very dry and you'll get fires. Does that sound familiar?
Yeah.
And if you live on the East Coast, you'll get hurricanes. So that should also sound familiar. We've got one more month to go in the hurricane season, and all we need is one hurricane to break the all-time record. So this is may we live in interesting times, as they say. The technical name for La Nina is El Nino Southern Oscillation. And the Southern Oscillation simply refers to south of the equator, the vibration between El Nino, a normal situation, and La Nina, the oscillation back and forth. This is very normal. This has been going on for hundreds and hundreds of years. The Spanish noticed it in the 1600s. And the cycle is about every 7 years, but it can be as little as 1 year and as long as 10 years. The name comes from El Nino. Normally they noticed El Nino around Christmas time. And you'll see a translation of El Nino being the little boy, but that's a bad translation. Whenever you say El Nino in Spanish, you're referring to the Christ child. And so this weather pattern, El Nino, came up around something's going on there. Anyway, so this was El Nino came from around Christmas time. The opposite is La Nina, as we'll see. Way back in my other things, you learned about the gyre. So around the Pacific Ocean, there is a very large counterclockwise rotation of air called the gyre. And every ocean has one. And this is called the North Pacific gyre. And there's one in the South Pacific as well. This is another picture of it. It's caused by high pressure. This is where the Pacific garbage patch would be, right around in this area and around in Hawaii, wherever the center of the gyre is. And you can see the clockwise rotation of air. What we're looking at now is going to be the bottom part of this gyre here. And you notice that the trend is from the Americas to Asia. I'm going to use a generalized term. So you're looking at wind and water, which is being pushed from the east to the west. If we look at the top, this is the equator. We have the bottom end of the gyre. The winds are pushing the air from the Americas to Asia, and we're also pushing water. On the other side, on the south, the gyre is opposite. You know, everything's opposite down there. Everybody's hanging upside down. And so the gyres go counterclockwise. And so again, this tendency is to push the air and the water from the Americas to Asia. This is called the intertropical zone. This is a sidewise version of it. These are the trade winds. So the wind is pushing from America to Asia. It's heating up as it goes across the ocean. It's quite warm on this side. And then it rises up, warm air rises. It's very moist. And so it's shedding its water as it rises. And it comes back here as cold, dry air. And this is called a Walker circulation. The same thing is happening in the ocean. The current is pushing from America to Asia, and then everything has to balance out. So it comes back around here as cold water and comes up here especially off of Peru. This is the most prolific fishing zone in the entire world on a tonnage basis because of all of the nutrients that are pulled up by this trade wind pattern here. As this wind and this water moves all the way across the Pacific Ocean, it warms up. So right here, you have a large concentration of very warm water. The nickname is the blob. You'll hear the blob once in a while, especially in an El Nino. There's a lot of very warm water, And also, since the wind is pushing this water and the current is pushing the water, the Pacific Ocean is higher in Asia than it is in the Americas. It's about 1.5 feet higher. That's a lot of water, and it's very, very warm. And so you expect here in Asia that it would be humid. You'd get a lot of rain, monsoon type stuff. Now, what happens if the trade winds fall off or even stop? The ocean wants to equilibrize itself. In other words, it wants to become level. And so this blob of warm water drifts back towards the Americas. This is an El Nino. The exact opposite is La Nina. If the winds are very strong, they push more water towards Asia, more water, more air goes there, more rain comes up, more heat. So now you've got, in a La Nina in Asia, you've got floods, you've got cyclones, typhoons, they call them in those, those are hurricanes. They call them cyclones over there, and typhoons. And it's very, very difficult. So we should be seeing pictures of Bangladesh where the roads are all flooded out. You'll see floods everywhere. And very, 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 very more hurricanes. So that should sound familiar to you. And then over on this side, you've got cooler, drier air coming down. This is what makes California so pleasant. So that's what causes the El Nino and the La Nina. Again, here's another picture of it. We've got stronger trade winds. You've got higher sea level. You've got clouds. It's hot. The air is rising. You're getting rain, and then the circulation comes back here. And over in this section, we have high pressure, dry air.
Bob?
Yes.
I have a question.
Yes.
A couple of weeks ago, we had a conversation about sea mammal communication, whale communication, and how that was most effective within the thermocline.
Okay. Yeah.
Is the difference in depth of the thermocline substantial in the Far East as opposed to the North American coast?
Yeah, let me see if I can get that picture back again. You can see right here, by the way, for all the rest of you, the thermocline is the temperature difference between very, very cold deep water and the warmer, more surface water. And it's a very, very demarcation. These waters do not mix. And so the submarines hide under here. They can't, the sonar bounces off the thermocline. So the answer is yes, it's much, much deeper in the Asian side and much shallower on the American side, yes. And you notice the thermocline slopes down and the water slopes up. So it's happening in both directions. Did that answer your question, Bob?
Yeah. It was fascinating in looking into thermocline as used or as enjoyed by the marine mammals. They gave a typical depth of, I believe, 660 feet, which of course is highly variable depending on location, water temperature, et cetera, but they didn't give boundaries of what is a shallow thermocline on the North American coast, or how much deeper is it over on the Asian coast?
Yeah, it's not some constant number, unfortunately.
No, they didn't say that. It was just an average. They picked because they had to do calculations about the intensity of communication and how far sound traveled and so forth. So you need a fixed number to come up with answers to questions like that.
Uh-huh. Yeah, on the nuclear submarines, they're very interested. They always want to stay down in the colder air and the colder waters because the typical methods of finding submarines are defeated by the thermocline and they hide under it.
Indeed.
Yeah, this is
Bob.
Yeah, go ahead.
Question: the hurricanes that come to the east coast here, what causes them? Because obviously there's not an El Nino over there.
There is a very, very mild El Nino, La Nina situation. And right now we've got a blob in the Caribbean and just to the east of the Caribbean, if you can picture that out in the Atlantic Ocean, the water is something like 72 to 74 degrees, which is very hot. And that's exactly what's causing the hurricanes. And so a La Nina situation causes that. Now notice the east coast of the United States, let me put this back. The east coast of the United States would represent the Asia and the Atlantic Ocean, and Europe would represent America. So the same situation is happening, but not quite so much. The reason for that is that the Atlantic high changes from winter to summer. And so in some part of the year, it's off of Bermuda, and it's called the Bermuda High. And then the high pressure moves all the way across the Atlantic Ocean to the Azores Islands off of Africa. And then it's called the Azores High. Whereas our Pacific high is relatively stable. And the shifting of that high causes a slightly different situation. But
Thank
you know,
you.
the east coast of the United States, we think of it as hot and humid, right? And that's because of the blob. and the west coast of the United States is nice and cool and dry, and that's because of the cold air coming down and dry air.
Thank you.
So this
Bob?
yeah.
Why is it that that surf is bigger with El Nino and smaller with La Nina as a general rule?
Try that question again.
Why is it that the surf tends to be bigger on an El Nino and smaller on a La Nina situation?
I don't know. I wasn't even aware of that.
Yeah, it's kind of goes with the El Nino has the I think it's the warmer water, the bigger surf, and La Nina has a smaller surf usually.
Oh, I don't know. That'd be a nice thing to write a docent paper on. This is a typical El Nino. You can see the blob is over by the American coast. Would be warm water. And the La Nina here is the cold. It's not called a blob, but it's definitely a cold air. And this would be upwelling from the coast and traveling towards the east, towards the west, I'm sorry, traveling from America. So that when you have a La Nina, which is right now, we've got a cold air and cold water situation going here. Now, what does this all have to do with our weather? Okay, so to remind you, the jet stream, and the one we're talking about is called the polar jet stream, and it should be a nice round circle. It looks like a tube of very fast air, and if it behaves itself, it's up in Canada. It doesn't come down into the United States, and so we can just ignore it pretty much. And this is the polar jet stream. There's another jet stream below us that, if it's well behaved, it stays in Mexico, called the subtropical jet stream. And these are the demarcations between the cells, the Hadley cells and the Ferrel cells that I mentioned about in my weather talk. What you need to know is that the polar jet stream is a block from the very cold North Pole air and the temperate air that we have in the United States. So as long as the jet stream is behaving itself, it contains this cold polar air up in the North Pole, and we can enjoy our nice weather here in the temperate zones. The same thing with the Mexico jet stream. If it's behaving itself, it keeps the hot, moist air from the tropics from coming up and bugging us in the United States. So we're kind of in between these two jet streams, is exactly where we want to be, not hot, not cold. That's if everything's good. So this is another picture. This is a picture here now of a well-behaved jet stream. It's going around the Earth at about the latitude of Canada. You can see there's a Hudson's Bay up there, and it's pretty much staying up in Canada and behaving itself. What drives the jet stream is the difference between the temperature in the North Pole, which is in theory cold, and the temperature at the equator, which is hot. And the attempts to equalize these temperatures causes the winds to flow and the cells, the Hadley cells and so on to form. And what that does is it drives these jet streams and gives them the energy. So what makes this go fast is the cold temperature at the North Pole and the warm temperature at the equator. Now, when that breaks down, the waves slow down. There's been a noticeable slowing in the jet stream, and instead of behaving itself, it starts to undulate and make these waves. And in a strong La Nina, we get a very strong wave like this. and it's going much slower. And so it doesn't have the energy to maintain its normal thing. Then eventually it goes back to normal again. So let's take a closer look at this. This is a well-behaved jet stream. It's up in Canada, if you notice. And up above here, this would be the cold polar air. And here, this is the nice temperate air. And then the Mexico jet stream would be down here, keeping the tropical air away from us too. So this is what it is when everything's nice. When we get a La Nina, the Pacific high starts to go into the coast of the United States. And what happens is you get what we call a ridge of high pressure. This is called a ridge of high pressure. And to balance it out, everything has to balance. Then you get a trough of low pressure down here. And so this is the undulation in the wave. And for some reason, it stalls off the coast. Quite normally in a La Nina situation, that's called a Greenland block. We're not totally sure why this happens, but in a typical La Nina, you've got a high pressure ridge here and a low pressure trough. Now, under high pressure conditions, you remember this is going to be a warm, dry air. And this is cold North Pole air coming down. So here's an example of what it looks like. So here we have a ridge of high pressure coming up here. And then it dips down and into a trough of low pressure. You've got cold Arctic air coming down. And you're going to hear different versions of what the predictions are going to be, and that depends on how high this ridge is and how low this trough is. Right now, they're saying that we in the West are going to be underneath a high pressure ridge. What that means is it's going to be warm and dry. Think drought. And then just what we need is another drought. And they're saying it's not going to go as high as Seattle. So up in the Pacific Northwest, it's going to be very rainy because the maritime polar air is going to be coming in here and giving them a lot of rain. Sorry, not necessarily snow, but rain. On the East Coast, pretty much guaranteed that we're going to get this cold polar air coming down here. So if you live in Buffalo, New York, and you like horizontal snow and sleet and cold snaps, you're going to love the weather. So that the East Coast should really eat it this year, if I'm right. The only question is, how far is this trough? This is what they're arguing about. Is it going to go all the way down to the Gulf Coast? And if it does, Georgia will be getting snowstorms. Alabama will be getting snowstorms. They're saying right now that's probably not going to happen. Let's see, whoops. They're saying it's going to probably look like this. So that the high pressure is going to be on this one, and this whole area of the West Coast will be pretty dry. Seattle's in the Pacific Northwest is going to be getting rain. The East is going to be getting snow. And this is probably going to come down right like this. And so then in the South, you're going to have this cold polar air coming down, and you're going to have the warm tropical maritime air coming up. And so now you're going to get a cold front and a warm front hitting each other. And this is typically gives thunderstorms, tornadoes, lots of rain. So they're predicting a very warm but wet South. And we're going to be getting a warm and dry winter. The Northeast will be getting rain, and the Northwest, will be getting rain, and the Northeast should be getting a very cold winter. So is there any questions on that? Yep.
Well, Bob, I don't need to look at the news. You just explained everything so perfectly. Thank you.
You might be hearing the words polar vortex.
Yeah, they do say that a lot. So you really explained it. Thank you.
Well, the polar vortex is another jet stream that's very different up around the North Pole. And it's much higher and much stronger. and it's weakening also. And when it weakens, if it breaks up, and sometimes it'll come down in this, lost my cursor here. Oh, here it is. It'll come down into the northwest. And that's really bad, because that's literally the North Pole. And the polar vortex contains that really cold North Pole temperatures. And when it breaks up and when it comes down, that really gives the cold weather. That's where you get the below zero stuff and really bad weather. And that's kind of a crapshoot. They can't really predict it. They're saying it's going to weaken and break up, but we don't know. We'll find out in January probably.
I have a question. It seems like every year is either an El Nino or a La Nina, but there's years where there's neither, right? There's just years where it's like typical.
Yeah, last year we had an El Nino, and they typically follow each other, one after the other, and then there might be a 5 to 8 year period where there'll be nothing.
Okay.
And that's where you get the ENSO, ENSO, El Nino Southern Oscillation, and these oscillation periods are very variable. So they do, one follows the other usually. That's the typical situation, yeah.
Okay, thank you.
Bob,
Yeah.
I would like to know what causes high pressure.
Okay, high pressure is caused by descending air. And if we go back to that cell, for example, this air is coming down to balance out the air, which is going up on the other side. And as this air comes down, it's like a bicycle pump. It's pushing down on the earth. And when you pump up a tire with a bicycle pump, the bicycle pump heats up. And so this air coming down is just like a pump that pushes the air down, heats it up. That's what causes the deserts in California, by the way. There's a large cell called the Hadley cell, which is going north-south. And that air is coming down right where we live and pushing down against the earth. And that causes the high pressure and the hot, dry air, which is our deserts.
And how will global warming affect the movement of the jet stream?
Right now, the Arctic is warming about twice as fast as the equator. And remember, I said that that these jet streams are driven by the temperature difference between the North Pole and the equator. So as the Arctic warms up, the strength of the jet stream is going to die out. I shouldn't say die out, but it'll weaken. And they've actually measured this. The jet stream is averaging a slower temperature than a slower speed, than it was before. And that causes oscillations. And that oscillation then is what I explained is happening. So we're more likely to get droughts in the west part of the United States and colder, wetter in the east. That's why they call it climate change rather than global warming, because one side of the country can be like right now, where we're in a heat wave, and the other side might be getting snow. What's happening right now? There's snowing in the east, and we're boiling wet here in the west. So everything's got to be more extreme, is what they're saying.
Bob, I have a question.
Yeah.
It may not be related to the El Nino and La Nina, but it is a weather question regards to the Santa Ana winds, because we are in a heat wave and the Santa Ana winds don't help. So does it affect the Santa Ana winds, or are the winds caused by changes?
Yeah, the Santa Ana winds are caused by high pressure. In the Midwest, actually in like Colorado and in that particular area, the West, but way inland. And that's usually starts out very cold. It also can be a trough of cold air coming in. And what it does is it's under high pressure, that is, it's descending, and it hits our mountains, goes up the mountains, cools off even more, and then it comes down off the side of the mountain and compresses, like the bicycle pump. And by the time it gets to the sea level where we live, it's quite hot and blows from the mountains out to the ocean, as opposed to our normal with, and that's because the air is coming from the plains area of the United States. They have a whole section on that. I could actually you give that in the weather when I do the weather, but it's very interesting. Yes, and we do have a Santana wind right now. Yeah.
Thank you.
Okay, any last questions for Bob?